Explain why the function is discontinuous at the given number a. Sketch the graph of the function. A is equal to 0 here, and the function f of x is equal to e to the x if x is less than 0, and f of x is equal to x squared if x is greater than or equal to 0. So we need to figure out what does the limit as x approaches 0 from the left of this function equal. Well, we look here, and this represents 0 from the left, so that means we're going to look at the function as x approaches 0 to be e to the x. So let's plug in 0 into the function, and we get e to the 0, which is equal to 1. Now, if we take a look at the limit as x approaches 0 from the right of this function, well, here we have x is greater than or equal to 0, which is approaching 0 from the right. So as the limit is approaching 0 from the right of the function x squared, we have 0 squared, which is equal to 0. So what does that tell us? Well, that tells us that the limit as x is approaching 0 of the function does not exist because these two are not equal to each other. And so therefore, since it does not exist, then we can say the function f is discontinuous at x is equal to 0, or at a is equal to 0. Now let's go ahead and graph this function, because they want us to sketch the graph. So we have e to the x, and it has the restriction of x less than 0. And then we have x squared, where the restriction is x is greater than or equal to 0. So therefore, here is our graph. Now let's go ahead and label that. So we know that the first graph here represents the function f of x, which is equal to e to the x, where x is less than 0. So that means here that at 0, 1, we have an open circle. Now we take a look at this graph, and this graph represents f of x, which is equal to x squared, where x is greater than or equal to 0. That means that we have a closed dot here at the point 0, 0.